It is Dhaka, 1924, and a young physicist named Satyendranath Bose, or SN Bose, had an epiphany to a problem that stumped even Albert Einstein. Planck's radiation law, a pillar of quantum theory, bore a logical flaw. And Bose had just the solution, a simple, elegant derivation that no one had thought of. He sent his paper to the prestigious philosophical magazine in Britain, but it was rejected without reason. But Bose did not give up. He sent his draft again, this time directly to someone he revered, the most celebrated physicist of the time, Albert Einstein. Einstein was impressed. So impressed, he personally translated Bose's paper into German and had it published in the journal Zeitschrift für Physik later that year. In some ways, Einstein and Bose were alike. Neither had a PhD when they made the biggest discoveries. Einstein had E equals mc squared to his credit when still a 25-year-old young man. Bose too was a fresh postgraduate when he laid foundations for what became quantum statistics. In classical physics, the Maxwell-Boltzmann distribution that governs how gas atoms are populated in different speed brackets fails to apply to quantum particles. Bose discovered a similar statistic for particles like photons, now called the Bose-Einstein statistics. In the bizarre world of quantum physics, it matters how you count particles. Two photons with the same energy state are indistinguishable from each other. Although this is a known fact, Bose realized physicists had not properly applied this to the treatment of Planck's radiation law, from which it's possible to decode the underlying quantum statistics, describing how photons populate different frequency or energy brackets. With Einstein's support, Bose's work helped unlock an entirely new way of looking at matter. Together, they laid the groundwork for what would later be called the Bose-Einstein condensate. Decades later, in 2001, scientists finally created this exotic state of matter, where atoms near absolute zero behave like a single quantum entity. It won a Nobel Prize. All this while, Bose, who passed away in 1974, never quite received his due with a Nobel of his own. The Nobel Committee had dismissed his work as a minor technical advance, but hindsight tells another story. Bose never seemed to mind. "I have got all the recognition I deserve," he once said, quiet, modest, but content with the stunning achievement of his own work. Still, in India, where he lived and worked, his legacy is barely remembered. A Padma Vibhushan institute in his name, but in classrooms and conversation, it's all but silence. Among scientists, though, his name lives on. The British physicist Paul Dirac coined bosons in Bose's honor. The media popular God particle, the Higgs boson, carries a bit of Bose as much as it does of Peter Higgs, who shared the 2013 Nobel Prize in Physics with Francois Anglet for producing the hypothesis. History has overlooked many like Bose, scientific pioneers from colonized nations whose genius bloomed despite the odds. Telling their stories is not just about honoring the past, it's about rewriting who we celebrate, who we remember, and who we learn from. Satyendranath Bose did not ask for recognition, but a century later, it is time we gave it to him.